Hi everybody. Today we are going to talk about continuity and how we can locate vertical and horizontal asymptotes, and we will talk about the definition of derivative, or how we can differentiate by using the 4 steps derivative. Anyway, now the function is said to be continuous at a given point if the limit exists at that point. For example, continuity. We have different types of functions. Let's start with polynomials. Now, polynomials, they are continuous everywhere. It means that the limit exists everywhere. Polynomials, just to remind you, they are continuous everywhere. Polynomials such as anything at the form of ax power n. It means no rational, no radical. Whenever you don't see a rational or a radical in the function as a polynomial, then it's continuous everywhere. Now let's go for rational. If I have a rational function, for example, f of x over g of x, then here you will say the function is continuous. Let's write it as a shortcut, continuous everywhere, except where g of x is equal to 0. In another word, just to find where the rational function is discontinuous, then you only solve denominator, g of x, which later on will be also the vertical asymptote. Now finally, let's go for the radicals or the roots. Now the radicals, we have 2 types. If I have an even root or an odd root. Odd root, such example, cube root, 5th root, 7th root, and so on. And for the even roots, such as square root, 4th root, and so on. Now, for the square root, we will say the function is continuous everywhere where x is more than or 0. But for odd root, it will be continuous everywhere, such as polynomials. Same as polynomials, continuous everywhere. Now, let's take one example for each. Identify where each function is continuous. For example, f of x equals 3x power 4 minus 10x plus 3. Now, as you can see, it's a polynomial. So we'll say it's continuous everywhere. Continuous everywhere. We don't have any exceptions here. It's continuous everywhere. Now, if I have f of x equals 3x minus 10 over, for example, x squared minus 16, then we will say, okay, this is rational. Then we are going to solve only denominator, where the function is not continuous at denominator equals to 0. Then we will say x squared minus 16 is 0. Then x squared is 16. Then you will use square root plus or minus. Whenever you use an even root, then you have to use plus or minus, not only for square root. Then it will be plus or minus 4. Then here we will say the function is continuous, except, of course, continuous everywhere, except at x equals plus or minus 4. That's about rational. Now, regarding radical, we say that f of x is equal to 2x minus 10. As you can see, it's a square root. It's an even root. Then, since it's an even, then we will say 2x minus 10 has to be greater than or 0. However, 2x is greater than or 10, then x is greater than or 5. So in this case, we will say that the function is continuous where x is greater than or equal to 5. So the function is continuous from 5 to infinity. Now, let's take the same example, but let's take it as an odd root. Fifth, for example, 2x minus 10. Then here, directly we'll say the function is continuous everywhere. And this is regarding continuity. Now, let's go for locating horizontal and vertical asymptotes. Now, if you have f of x over g of x, to identify where we have vertical asymptotes, VA as vertical asymptote, then you only solve g of x, the denominator. Now, regarding horizontal asymptote, we have quite long story for horizontal asymptote. Horizontal asymptote. Now, horizontal asymptote, then you have to use limit, where x approaches to infinity. In this case, what you do, you take the highest degree in numerator in f of x over the highest degree in denominator, which is g of x. Now, if you check the degree, now we are talking about degrees only. F of x over g of x. Now we are talking about degree. Degree, it means the highest degree or the highest power in numerator or highest power in denominator. Now degree. Now if the degree of f of x or denominator is greater than the degree of denominator, as limit x approaches to infinity, you would say infinity. It means we have no horizontal asymptote. How we are going to reach infinity to grab the horizontal asymptote? So whenever the degree of numerator is greater than denominator, then you will say no horizontal asymptote, or you may say just none. Now, the second case, if the degree of numerator and degree of denominator are equal, then you only simplify. We will come for it later. However, finally, if the degree of numerator is less than degree of denominator, then directly you say we have horizontal asymptote at y equals 0. Sometimes you have no vertical asymptote because there is no zeros for the denominator. And sometimes you have no horizontal asymptote. Maybe a function doesn't have any asymptote. Now let's take one example. Let's say that we have f of x is equal to 3x minus 10 over 2x squared minus 5. Or let's just say 50. Now let's start with locating vertical asymptote. To locate the vertical asymptote, we know we only solve denominator, which reminds us of continuity. So here you will say 2x squared minus 50 is equal to 0. 2x squared is 50. X squared is 25. So x is plus or minus 5. So here we have vertical asymptotes at x equals 5 or minus 5. Just to remind you of continuity, then the function here is continuous everywhere except at 5 and minus 5. Now let's go for horizontal asymptote. Horizontal asymptote, we check the degree of numerator with the degree of denominator. Now, as you can see, degree of numerator, dn as degree of numerator, is less than degree of denominator. So in this case, directly we will say that we have horizontal asymptote at y equals 0. And so on, you apply the other degrees. You just for horizontal, you just compare the degrees. If numerator is greater than the degree of denominator, then you will say no horizontal asymptote. If both are equal, for example, let's say that we have f of x equals 5x squared minus 10 over 3x squared plus 5. Now, in this example, if you solve for denominator, you will have no vertical asymptotes. Why is that? Because For vertical asymptote, you'll say 3x squared plus 5 is equal to 0. Then you will say 3x squared is equal to minus 5. Then x squared is minus 5 over 3. Whenever you square root for a negative radicand, then it is undefined. So here we have no vertical asymptote. Now we go for horizontal asymptote. You are going to compare only the degrees. Now numerator and denominator, they have the same degree. So we have limit x approaches to infinity. You take the highest degree over the highest degree in denominator. You will have 5x squared over 3x squared. As we said, degree of numerator is equal to degree of denominator. Then you just simplify. Then you have horizontal asymptote at y equals 5 over 3. Now, this is everything regarding locating horizontal and vertical asymptotes. Now let's go for the basic derivatives, and we will start with differentiating by using definition, or which we call the 4 steps derivative. Now, in order to find a derivative by using the 4 steps derivative, let's say that limit h approaches to 0, f of x plus h minus f of x over h. We use this limit where h approaches to 0 to find a derivative. Later on, once we start differentiating by using derivative rules, then you can compare the answers and they will be the same. However, now, if I want to differentiate a function by using definition or the 4 steps, let's say that you have f of x is equal to 3x minus 10. Now, step 1, you have to find f of x plus h. That means you replace each x in f of x by x plus h. Now, whatever you have between parentheses, it means you have to replace it instead of x. So here we have x plus h, we are going to replace it instead of x. Plug in, then you will have 3 multiplied by, instead of x, now we have x plus h. Minus 10. Then you simplify. That will give you 3x plus 3h minus 10. Now, this is the first part. Now, I'll skip part 2, and I will go just directly for part 3. And I will call it the second step. So in this case, we have only 3 steps rather than 4 steps. Now, the second step, you have to find f of x plus h minus f of x. Now, what we have for f of x plus h? We have this one here, which is 3x. So now we are finding f of x plus h minus f of x. F of x plus h, which is 3x plus 3h minus 10, minus f of x itself, which is 3x minus 10. That is our f of x. 3x minus 10. Then you simplify 3x minus 3x, add minus 10 minus minus 10, and that will leave you with 3h only. Now the third step, where you evaluate the whole limit as limit h approaches to 0. Now f of x plus h minus f of x, all of it, it gave you only 3h. So we have 3h. All over h. Now we simplify h with h. So the final derivative, it's only 3. So we can say derivative of f of x, it's only 3. This is how we find derivative by definition, or the 4 steps derivative, which here became 2 steps or 3 steps only. Because this is step 3, where you evaluate the limit. And we will take one more example in case if we have, for example, power 2 or quadratic function. We say that f of x equals x squared plus 3x. Then say, okay, first step, we find f of x plus h. So now we plug x plus h instead of each x you have. Then you'll have x plus h power 2 plus 3 times x plus h. Now this one we can simplify it by multiplying it by itself or by using product rule. Now product rule states that if you have a plus or minus b, doesn't matter, all to power 2. Then you square first, then you'll have a squared plus or minus, depends what sign you have. Now in the middle, you have 2 multiplied by first, multiplied by second. So 2 times a is 2a, times b, then you have 2ab. Then finally plus square second. Now we will apply the same rule here. Square first, you will have x squared. We have plus 2 times x is 2x, times h is 2xh. Then square second, h squared. Or you can just multiply this binomial by itself. Plus, now we distribute this one, we simplify. 3x plus 3h. Now, this is f of x plus h. Now we go for the second step, which is f of x plus h minus f of x itself. So we will have x squared plus 2xh plus h squared plus 3x plus 3h. I know it's quite long, but it's simple once you simplify it. Minus f of x itself, which is x squared plus 3x. Now we simplify. X squared minus x squared and 3x minus 3x. So finally, you only have now let's take it here. So as a conclusion, we have 2xh plus h squared plus 3h. That's what remained from the simplification by subtraction. Now we evaluate the last part. Now we are ready for limit h approaches to 0. Because f of x plus h minus f of x, it is this one. So 2xh plus h squared plus 3h all over h. Now we simplify each h we have. Now 2xh, 2x will remain. H squared with h, 1h will remain. H with h plus 3. Then finally you evaluate the limit now. We have h approaches to 0, so we replace each h we have with 0. Then you will have 2x plus 0 plus 3. Then finally the derivative is 2x plus 3. Now, this is everything about differentiating by using definition. And hopefully next week, it would be a better week. And we are going to differentiate by using derivative rules, which is quite much easier than this. Till that time, you guys stay safe. Thank you very much.